Hey guys, this is Schuleman here. I'm coming to you from BSUFX. It's a company I created to offer my freelance skills to the TV commercials and film market. Um, I'm originally from a Maya background. I've been using Maya for about 8 years now, and I recently had the opportunity to join a project for a TV series doing some extra VFX onto live action plates over the last 10 months. The trick was that they wanted to use Houdini and I didn't know it at all. So it was quite a steep learning curve for me and well for anybody actually. And I thought that I'd do this tutorial to help some people out that are getting started in Houdini and maybe come from Maya and just some some workflows and some things to remember and to look out for and things to help you along with getting stuff started. Excuse me. I'm going to be doing some broad strokes in Houdini, so basically I'm just going to go from nothing to building some geometry, doing some light setups, but into shaders and doing some ROPs or render nodes and rendering it out just so you can get a kind of a feel for the workflow and how things need to work in Houdini. Yeah, so let's get started. First off, I'll just go over the interface in general. Like I said, broad strokes. I'm not going to go into each and every little attribute, mostly because I don't know each and every little attribute, but because these are just the ones that I've used in a production environment so far. So obviously, top left, you've got File, Edit, Render, Windows, Assets, and Help. File is your menu where you get make new scenes, open files, save as, set projects, imports and exports. Imports and exports are here as a function, but what everything that happens in Houdini is going to be a node that's created linking to a file on your hard drive or to other parts in Houdini or referencing scripts or something like that. So all these menu functions here, like import, geometry, and alembics, and all of that kind of stuff, you can do basically on a nodes basis. So, for example, if I had to go import alembic scene, it would create the same nodes as if I tabbed here in the scene view and went alembic archive, and then linked to a file name and said update. It would do exactly the same thing. That's one of the things you'll realize about Houdini as we go along, is that there are many different ways to do the same thing. So yeah, that's the file section. When we save, this is Houdini effects. I was lucky enough to keep the license that I had for the project. Houdini effects is a .hip file. So you'll see I'll use a $hip function or expression or whatever to call the location of this where this file would be saved, or to call the name of the file that is saved. That's what the $hip function does. There's a couple of others. There's $hip, there's $fstart, $fend, $f, $f4, all that kind of stuff. But we'll get into that as we go along. Okay, so edits, this is edit section, your preferences, this is where you'll set up all your default preferences and stuff. Color settings is the one I want to talk about a little bit. By default, Houdini is set to work linearly. So your camera here is set to 2.2, and what that means is that everything in your viewport is going to come out sRGB, so you can see it on your monitor. When you render things like EXRs, you can render them linearly, but when you view them in your scene, it'll all come out sRGB, which is nice. Concerning textures, what's going to happen is Houdini's pretty smart, so it's going to figure out that you've got, for example, an EXR plugged into a texture, and it's going to go, okay, cool, this is probably a linear file, so it's going to make that input linear. The same if you plug in a JPEG, it's going to assume that it's sRGB if it's an 8-bit JPEG. So you can change those things if you want. It's just something to be aware of, that your linear file formats will, Houdini will assume that they're linear as with sRGB. Cool, so we're going to leave all of that default. Most of the stuff, I mean, you can just go through and have a look. Set keyframe here is shortcut K. I don't think I've ever used this, to be honest. I usually just right click, or I think it's shift middle click to set keyframes, or alt middle click, I can't remember exactly. Okay, so render nodes, well, render section, you've got create render nodes and all of this. You can create render nodes here, like if you can create a mantra or mantra PBR. All these are going to do is what you can do right here and just say, okay, I want, so I'm typing with one hand, I want a mantra node. So all it's going to do if you do this is do this. So if I go render, create render node, mantra node, there you can see another one pops up. Like I said, most functions are on completely node based. I don't think I've ever used this menu. I mean, there are other places to do things. Over here is all the windows that you can get as a floating window. For example, you can have your text list as a floating window. You can have your render view, if I can find it. Okay, so you'll just make a new floating window and go render view, and that's what I usually do when I'm doing look dev stuff, so I can interact in the viewport here and also in get a real-time preview in the render here. Let's see. So your desktops here, I mean, you get animate, which is just a different way of looking at things. Build, which is one I was on, which is slightly changed actually. Images for more of a comp kind of thing. What you'll find is that your Houdini, when you open it, will look more like this. So, excuse me. So you've got this, you've got your parameters and your node view here, and then your 3D view here. I just, because the nodes trees tend to be quite long, I just did this to make it easier to see the node tree, and you'll see what I mean as we go along. Especially since you work mainly in the node view, so it makes sense to have a nice big window. Assets are kind of like references. In Maya, you have to set a specific file format, an HDA. And when you do, it will basically group whatever node structures you have, create an asset of it, and then you can auto-load it whenever you load a scene, or if it's on a network drive or something. So you can do like a character that's fully done, or you can do a particle sim that you like, and you can just drop it in and play around with it every time, or like dynamic sim or whatever, you know. So yeah, you can make new assets, install asset libraries, all that kind of stuff. The All But Store here is where you'll go and buy assets online or download assets that people have uploaded for free. It's pretty powerful, but yeah, that's just something to look into and then help. So here on the left we've got all these tabs, which are basically just going to, whatever you do here, it's going to create in the node editor. So if I click it and I hit enter, it'll drop it in the middle, and then you'll see it's made a box object here with a box inside. Likewise, I can delete that, hit tab and type box, and it'll do it. Likewise, I can delete that, hit geometry, make a blank geometry node, kill this, and in here I can type box. So like I said, there's many ways to skin a cat and to do all of that. I rarely use these functions. especially the modifiers and stuff. I mean, this extract, I think there's actually, if I make a geonode here, there's probably an extract. Yeah, extract. No, there isn't. Okay. But yeah, it just depends what you want to do. Excuse me. What these buttons all do is they basically run a sequence of commands and build a node tree for you based on that. So they're like shortcuts almost, or presets. There's models, polygons, deform, textures. All these things can be done at the sub level on the node side, which is what I'll probably end up doing. Rigging characters, all this kind of stuff. Cloud effects is cool. Cloud effects, you can generate clouds from a given shape, which is kind of nice. Volume effects, I've actually never used any of these. I just do it with the nodes. You can add, well, swap between here, or you can add different sets and a new shelf and all kinds of stuff. So on the right here is where the meat really is. You've got lights and cameras, so you can create your camera here. Particles. What this does is basically, like I said, it is a script almost that it generates a whole bunch of nodes for you. So for example, if I go and create our tasty box, and I go, okay, source particles from there, what it's going to do is it's going to, in this box, it's going to reference that box and box source here, and it's going to build all these nodes, connect them properly, and then do an export node or a .io node for your exporting your caches and stuff. And in here, then you can come and when you push play, you'll see and nothing happens because I deleted that, of course. So when you push play, then your sim will run. Likewise, you can go, okay, no, I don't want that, I want something else, etc. Cool. Let's just kill that. And so grains is like simulating sands, well, sand. So beach sand, wet sand, all that kind of stuff. It's pretty new in Houdini, in this Houdini version, which is 14. Rigid bodies is exactly that. So you'll select your object and make rigid bodies static or ground plane, stuff like that. Again, you can do this all manually. This just sets up a whole node tree for you and connects it all properly so it all works. Particle fluids is flip fluids. So it's for liquid simulations, stuff like that. I've used this quite a lot. It's pretty powerful. Some very cool stuff. And also, just something to remember, I have used RealFlow before, and it was a bit of an issue to generate mist, and then you've got to render it in Mentoray, in Maya, and you've got to use various toolkits and stuff like that. Here, anything that you can make in Houdini will render in Houdini with Mantra, which is kind of cool. Like, everything renders and everything is adjustable and customizable to the nth degree. I mean, you can go down all the way down to the bare code if you really want to, which is what makes it really powerful. Ocean effects is exactly what it says. Fluid containers and populate containers. These are just various containers that will be automatically created when you put all these buttons. Container tools, painting, various temperatures and stuff. Pyro effects is your smoke and fire. Really powerful, really cool. Cloth sims, solid. This is more like a jiggle kind of jelly, organic tissue and stuff like that. That's basically what that is. Wires, I'm not really sure. Crowns is a crowd sim, and drive simulation is to export. Oh no, actually, this is adding various forces and stuff like that. Okay, cool. So here on the left, we've got move, rotate, scale, snap, in your component and object mode. So here you're in object mode. Here you'll be in components. So if you hold it, you get points, edges, primitives, which is like faces, and vertices, which is kind of like UVs. Breakpoints, I've never used, neither have I used any of this. What you will find is that this will pop on for some reason. Oh, go away. Anyway, so oh, there it is. What you'll find that I did is I modeled stuff in Maya, and I prep all my assets in Maya, and then I export it on Alembic, and I use that. I import that into Houdini, and it's just a better workflow for me. The modeling is a bit strange in Houdini for me. Like for example, you make your box, and then you go in here and you push enter to activate this node in your viewport, and then you'll go, okay, cool, I want this primitive, and then I've got to go, okay, I'll extrude this one, and you see it makes a node. And then if you go here, for example, and you go extrude this one, it'll make an additional node. So all this stuff is hidden in Maya, and you can delete history, which is basically like baking it out almost, in a way, which is why I don't model in Houdini. I mean, I'm not as efficient, so I'm going to have 1,000 nodes here trying to build something, which is not something I'm not prepared to do. Okay, cool. So let's see, what else do we have here? So this is your make big window, make small window. This drop down is everything to do with your interface, so you can rip off this tab, rip off a copy, split things, and all that kind of stuff. You've got tabs along here, which is scene view, animation editor, etc. You can right click and change these to whatever you want. I'm sure you saw me do it over there. So I can make this the text port, or I can make it the network view, or the scene view, or whatever. Likewise, I can make this the scene view if I want, or whatever. Animation editor is like the graph editor, but it is a little different. We'll get into that. Render view is the render view, is where you see your render previews. Composite view and motion effects are context-related views. You can do your own compositing within Houdini if you want. It's a node-based compositor. Motion effects is bringing in audio files or something like that to drive animation. And geometry spreadsheet is where you get a readout of basically everything that you have selected. So, for example, if I've got box, oh, sorry, in the wrong context here. If I've got a box, you'll see here I've got a box. There's 7 points, and these are the UVs numbered from 0 to 5 or whatever. There's 6 primitives, sorry, it starts at 0. And the object is a details view here, and you can go, okay. Now when you add things like velocity, you'll see there'll be a v, x, y, z, weight, all kinds of stuff. So this is just a readout, so you can see exactly what attributes are where and what's attached to what and whatever. Another way to do that is to make a box, and you can middle mouse on anything. Or any node, and it'll give you a readout. So it'll say, okay, this is a geo node, it's time dependent, it's been cooked, it took this long. Likewise, if you jump in, you can see, okay, this is 8.6 primitives, 24 polys, it has this attribute of p, it uses as much memory, all that kind of stuff. This is where it is. So yeah, pretty easy to get to all the information. Your cameras will come out here. If you make a new camera, then you'll select it here. If you hit space and you rotate, it'll throw you out of that view. So right now I'm using rotate, left, middle, and right mouse button. What you need to do if you're in your camera is you lock it off. So you lock it to your view, and then you can move it, and then unlock it and rotate out. It seems kind of a weird way to work, but it's actually quite cool. So if I grab this and I hit enter, nothing's going to happen. So yeah, so you can see you get your manipulators and all that kind of stuff. Yeah, cool. So let's just what was it again? Home grid. No, it's like reset construction plan or something. Oh, okay. So in your scene view here, you've got if you hit space 1, you get your perspective view. Space 2 is top. Space 3 is what? Front maybe. Space 3 is top, is front. Space 4 is right. Space 5 is UVs, and 1 again is your perspective view. So let's just create a camera quickly just to reset my view. Yeah, there we go. Cool. So yeah, your interfaces are here. So let's talk about contexts for a second. So in Houdini, everything works in a context situation where it's basically like grouping of specific things. So where we are right now in OBJ, which is your SOP level, surface operators. You can see it's a senior if you can. And this is where you'll do all your surface-based things. So building geometry, deforming stuff, all that kind of stuff. Then you have various other ones. You've got your channel or chops. So here you'll add, you'll bring in your file nodes and stuff like that, or you'll add a chop network, and in here you'll bring in a file node, and you'll load in your bclip or your audio file, whatever it happens to be. Image is where you'll do compositing. And for all of these, when you hit tab and you're in the actual image network, you'll see you'll get different menu options when you hit in your tab menu. So like this color or this hue curve won't be available in a subs level because it's for compositing and you wouldn't need it. OBJ is your subs level. Let me just show you this tree view. Out is your ROPS level or render operators. Shop is your shader operators, and Vex is your Vex context. So your Vex like Bob networks and stuff, which I don't think I've actually used this. It's like a scripting kind of language native to Houdini. Okay, so what you'll notice is that, for example, if I go add this to your node in here, and I kill it and I make it a sphere, okay? And then I go out here and I make another box network, again, obviously, and I go and I want to reference that sphere in here, I can do that. So I'll drop an object merge down, I'll reference here, and I'll get the box. So what's happened is the structure in Houdini, the object structure and everything works kind of like a Linux file system, where / is your root, which is where everything lives, and then you've got different folders for your different contexts, and then your objects will be in that context. So for example, if I'm here in my object merge, it's going to look for /obj /box /box1. That's the object it's going to bring in. So yeah, you can basically reference anything and everything via this network. So if you want to bring in chops, I don't think you can do it in here, but if you wanted to reference chops, that's how you do it. Or if you wanted to reference texture out of cops or your comping section, you could do that. And we actually do. I actually did do that a few times. So you can procedurally generate your own textures, or say you bring in a texture and it's too bright and you don't have Photoshop or something, then you can just take it into cops, add a levels node and pull it down or whatever, and then you reference that baked texture out. Cool. So contexts, like I said, is based here, but I mean, if you are going to render something, so let's just make our box. And let's say, okay, cool, now we want to render this box, so we need a mantra node, okay? Mantra node is like your render setting, so it tells mantra, which is your renderer, what cameras and all your settings. So say I want to do this and now I want to go back. So I want to put a shader, so I go here and I make a material, and that material is a displacement material, for example. Now when I want to go back to here, I've got to jump in here and I've got to go back up here and click here. So I find that a bit tedious, and it's an older way of working in Houdini, so it's separated everything, especially your dynamics and all that. But what you can see, the dot network actually isn't even here anymore. What I usually do now is if you hit tab, you can type ROP, for example, and you'll get a ROP network. So right now, if I'm here and I go mantra, nothing comes out. Or if I'm in here and I go mantra, nothing comes out. But if I'm in ROPs, I'm now in the outputs context, which is the same as here. Okay. And I'm using U and I to go in and out. So in is I and up is U. I use it quite a lot, just so you know. So if I tab here and I go mantra, there we go. Now I can do a mantra node. And similarly, I can reference those nodes properly because of this tree setup. So it's slash obj slash ropnet1 slash mantra. There we go, there it is. Instead of slash out slash mantra. I mean, it just works a lot better. I mean, you can come in here, you can do one for shop networks. So in here, you can create your materials if you want. You can do one for cops, which is your comping. You can do one for what else? Can you chops network? You can do. There we go, and it'll immediately pull you in, and it's in this context, and all those same. See, here's the audio functions and whatever. All those same menu functions that are available will be available in that context. You'll see when we create dynamics, like we did, it all makes this thing called an auto-dop network, which is exactly that. It is a dynamics context where all your dynamics happen. Yeah. Okay. And you can see I'm deleting things, and there's no funniness left in the scene. Whatever is in this node editor at whatever time, that's what's in the scene. There's nothing hidden from you. There's no like here in shops, there's this fault material which we created, we can kill it. Now this is, like I said, file new scene. It's exactly the same as a brand new scene. Okay, so that's context. So yeah, I think the best way to show you what needs to happen is to just build something. So let's do that. Let's go, and we're going to do a terrible scene. It's going to be a plane with a torus that drops and shadows, and then we're going to light render it out. Cool bananas. Let's do that. So first off, let's make our torus. So let's make our torus. Okay. Actually, you know what? Let's see if we can get. Oh no. What is it called now? Yes, primitives, platonic solids. So in here, it's going to make a platonic solid, and I want. Oh, where is that now? It's like a head pig. There's a pig I wanted to use. Test geometry, pig. Bang. Bangarang. Let's do that. So let's hop out here, and I'm going to call this pig. I think that's it's just going to look cooler than anything else. And we can break that pig and whatever. Let's see what else this makes. Tick list. No man. So let's go tree view. Yeah, so you can see it creates materials and all kinds of stuff for itself, but we'll override all of that stuff anyway. So, okay, so we've got our pig, and this is what's called an asset. You can see right here I can extract contents, or I can hop inside and everything's grayed out, which means it's locked. So if I right click and say allow editing, it goes red here, and then when I hop in I can change everything. So you can see this is referencing in a operation BGO, which is the pig head, and now it's connected to these materials and everything like that, which is lovely. So there's the pig head, there's the non-smooth pig head, I don't know. I think this is probably the... Okay, well we don't need that, or that. So let's just keep this one. That looks good. Oh, I hit W for wireframe, by the way. Cool beans. So I'm going to kill this, and I'm going to add a null right at the end here. So I'm going to name this null out. So what I'm doing, and then you'll see this workflow in Houdini all the time, is I'm adding a null right at the end, because if I want to reference this in to another part of Houdini, then I'll reference in this end node. So for example, if I want to reference this in somewhere and then I want to come back here and maybe shatter it or make a volume out of it or something, I can come in here and I can go, okay, I want to shatter it. So let's do scatter, and let's do Voronoi. Sorry, I can never say that. Let's do a Voronoi and connect it all up, and then you'll see if I switch, there you go, there you can see the Voronoi has actually come in and shattered everything nicely for us. Let's just make this 220. So there we go. We can do an exploded view, and then you see all the pieces that were created. Now, the cool thing about this is, say I don't want a pig's head, say I want a sphere. Say I want a sphere and this pig's head's too hardcore. I go and I make this a polygon sphere. There we go. It's added the same operation all the way down, and the material's not going to work because it's linking into a shopnet. I think that. Oh, the shopnet is here. Okay. The material is. Oh, it's grouping. It's looking for a group that isn't there. But anyway, so yeah, you can see that's working nicely. So that's a really cool way to work on proxies and do your animation and stuff, get it all right, and then come in and plug in a high-res version, and everything should just work. It'll go bake all the way down the chain, or cook all the way down the chain, and then your art node will just bring in the new object. Cool stuff. So you see, there we go. Our pig's head is amazing. And I mean, this is completely procedural again. So say I want to add more points. I've done my sim and I'm like, oh, I'm happy. Let's just undo that. So I've done my sim and I'm happy, but I'm like, oh no, that sim sucks. It's not detailed enough. I'll come back here and I'll add 100 points. There we go. It just updates it. And this is what is so cool about Houdini, is that everything is procedural. So you're never locked into doing anything really. Cool. Yeah, you can see it came in groups: pig's eyes, pig face, pig neck, pig throat. Yeah. Anyway, so let's hop out of here and let's actually extract contents of this, because I want pig to have everything in here. You can see it's going to freak out now because actually let me undo that. its file referencing is a little weird now. There we go. Because it's looking at, say, this texture here, it's looking for ODEF, up one level, up another level for this texture, which isn't there when you pull it all out and whatever. So we'll just leave it here for now. Cool, so operators. So that's the geonode is basically your shop node where all your geometry and stuff hangs out. What you can do here, you've got it's a like think of it like shapes and transforms. So inside here is your shape node in Maya, for example, or whatever's at the end, which defines what this all looks like. And then at the top is a transform node. So you got to translate, rotate, scale, pivot, all that kind of stuff. I generally do not translate from here unless it's something like a camera or a light or something that has like intricate workings on the inside that I don't want to mess with. What I'll usually do is I'll come in here and I'll add a transform node, okay, and then I'll animate this. There we go. Why is that not working? So my match current definition will will re-reference the same scene. Okay, y'all, see what's actually happening here is this is a display issue which happens in Houdini a little bit. Sometimes your display doesn't redraw properly. So this doesn't exist. It's not even here. It doesn't really matter what that is. But Houdini has still got it in there. So what we're going to do is we'll save this. Let's save as. We'll go to our C drive and we'll go to Houdini broad strokes and I'll call this peg drop version 1.hip. If you've got the non-commercial version, it's .nchip, I think. Indie version has its own file extension. Hip is a Houdini FX file format. What tends to happen is that non-commercial versions will export a file .nc hip, and you can open those in Houdini FX. So Houdini FX can basically open all files generated from any version of Houdini down. So, but like a non-commercial version, you can't open a .hip file, and there's no way to export the network into a hip file or whatever. You just basically have to rebuild it. SideFX does offer a service where you can convert all your NC hip files or hip NC files to .hip once. So you can't do it 3 times a week. You only get to do it once. But yeah. So let me close this and then I'll just reopen. Okay, cool. So let me reopen. I can come here recent, or I can go file open, and you can see here is the $hip function, which doesn't work because I don't have a hip file opened. So let's go to our broad strokes, open that. Now you'll see if I go open and I jump somewhere else, if I hit hip, it'll go to where my hip file is. This function you can also call in Houdini $hit $job as a reference to the file or the file name or the location or whatever. So textures can be $hip / texture / awesome JPEG, whatever it happens to be. Okay, so let's make a null, and I'm going to go call this out. Another reason for the out null is when I come in here and I make a geonode, for example, and I go object merge and I pull in the out null, you'll see out is at the top of this whole stack. So say you got 50,000, well, 50 nodes, not 50,000. Say you got 50 nodes. The one with a capital letter will be at the top. So that's a way to quickly reference between things. Cool. Yeah, so the out null, the capital letters are at the top, so it's a way to quickly reference between things. So if I pull that in, there you go. It's got /obj/pig/out, and you're good to go. Another thing you can do is you can have multiple nulls, obviously. So say I've got this, and I lay down another transform, and I'll throw this here, and I'll go out origin, for example. This one is now pulling in the same geometry. It's not transforming it up. It is keeping the transform here, and this null is now here. So you've got one object being referenced, or file, or whatever, on Lembic, and you can just branch off and do multiple functions like this. So this is, for example, how I will do materials. So I'll come here, I'll add a switch node, and I'll add a material node for like beauty, and then I'll copy paste, add one for shadow, and I'll copy paste and add one for, I don't know, matte, and then this will come in here, and then what you'll do is you'll will swap this, and it will switch between them all without having to create extra node trees or anything like that. But yeah, we're getting ahead of ourselves, so let's just do this again. And yeah, so what are we going to do is we are going to kill that. So we got our pig. Okay, our pig is high over here. Now what we want to do is we want to drop it on the floor. So first off, let's go and make our pig a rigid body. So you get static and dynamic. So static is obviously static, it doesn't move, can't be moved unless by a transform node, and dynamic will obey all the laws in the simulation, so gravity or whatever, and act dynamically. So I'm going to hit that, and with my pig selected, and you can see here it's made an auto-dop network. So in the pig, you'll see it's made a rest node, which is going to calculate the rest position, and then it's a dop import node. Now what this does is it imports the information out of the dop node, out of the dop network. So what happens in here is this sim runs, and whatever point positions come out at the end of it will get re-imported here. So if you wanted to, I don't know, have a separate sim for particles hitting this while it's bouncing or whatever, you would reference this, because this is the result of the dop network here. You can also reference this output node, but this dop import node is better set up to do that. Another one is .io, you'll probably see, which does the same thing, except it doesn't have this tree attached. It just directly, you saw it with particles, it'll just directly reference your particles in based on a network nodes and everything. And it comes with a nifty little cache tab, so you can cache stuff and whatever. See, here's that $hip function I was talking about. So that's basically going to go where your hip file is saved, make a folder called geo, and in there a folder called $hip name, which is pigdrop version 1, .os, which is going to reference this node name, $f, which is going to reference your frame number, and .bgo.sc. .bgo is like a geometry file format, and well, it's a Houdini native cache format, and .sc is just a compressed version of that. Okay, So now that we have our pig, let's play. So obviously it is playing like crazy. I'm going to switch on real-time playback, I think it is. Yeah, there we go. So this is going to play based on our global animation settings, which is down here. So 24 frames a second, we'll just make that 25. Start frame 1 to 250, so let's make that 250 and hit apply. Yeah, so while I'm here, you'll see here you got start, end, and ink. Okay, this is just going to reference your frame start and frame end. Now, $F start and $F end are functions that will call the start and end of your simulation or of your timeline. If you do this, it is not going to change F end, it will just clip it to whatever your timeline views. So it's going to pull $F start and $F end from here. So if you want to render a reference $F start and F end in a render ROP, for example, or something like that, you have to do it here. And then you hit apply, and then it will take effect. So you can see F end here. So if I change this to 100 and hit F end, this is now 100. No matter what this says, that's as long as the sim will run. Okay, so let's do 250 and hit apply and play every frame, but no faster than frames per second. Cool. So yeah, again, we've got our sim running. Happy days. We've got our pig geometry brought in as an RBD object. This merge node just means you can go and plug in loads of them instead of stacking them up. So this merge is a collide relationship, so it's going to collide whatever nodes are plugged in here. Rigid body is your solver, so this is where you'll do things like substeps, what your solver engine is bullet, iterations, fractions, and all that kind of stuff. Then you got another merge node, again, mutual collide relationship. What you'll find is this will be like where, say you had a pyro sim running here, which will look like this, except it will be connected into a pyro solver. And then it'll plug in here. So you'll get pyro, or smoke. You get a smoke solver, you can smoke objects. Yeah, you can, there's a whole bunch of cool things in here. Then gravity and output. The way that dynamics works opposed to the way that SOPs works is SOPs, it's basically comes through here, then calculates what's happening here, moves to the next node, calculates what's happening here, moves to the next node, and so on. DOPS isn't like that. It's kind of like, well, it is and it isn't. Here, the output flag is at the bottom, so everything's going to be calculated. But here, now the gravity won't be calculated, or the output node. But everything is kind of calculated at the same time. So if you can put a gravity node in, well, I wouldn't put a gravity node in here. You could put a force node in here, for example, although you would put it on the other side. And it doesn't matter that it's above or whatever, it will still get calculated as one function, or as one calculation. Obviously, you've got your substeps here, start frames. So say you started at like 1,000, you put 1,000 in here. Yeah, cool stuff. So that drops. Now let's make a floor. I can either come here and make a grid, which I'll do later, or I can hit this ground plane. So what this ground plane does is it brings in this geometry, which is an infinite floor collider, which is kind of handy. So your ground plane, I'm just pushing L to reorder this. So your ground plane will come in here. It will run in a static solver because it's not a rigid body, and then it'll get merged together with this, and then gravity will be applied and everything. See what I'm saying? Like, gravity acts here and no gravity's here, but the gravity is below here. You would think in a subs environment that this gravity would act on this as well, but it doesn't. It just means it's included in the calculation as a whole. Cool. So let's drop this bad boy again. Booyah. Pig's head dropped. Amazing. What is cool about this and procedural about this again is, say for example I wanted to not do that, rotate this pig's head. I didn't like its animation or whatever. I don't have to go and resim now. Well, I will have to resim, but I mean it doesn't break my entire node. So now it'll just drop from there. And you'll come in here, initial state, and go velocity of x of 10, for example. Not do that. And then it'll bounce to the down the x axis here based on this of 10. Your world's base 10. Same thing, I can add 10 in the rotations velocity and nothing happens. Yeah. But anyway, so that's what you can do. You can kick things up if you want. So let's kick it up. Oh, too much. You can, let's do like 5 and 0. So you can tweak your animations like that. So now we've got this simmed. Let's do something else. Let's go in here and let's break this. Let's shatter this pig, and then we'll drop it because that's fun. So let's add a scatter. First off, what we're going to have to do is scatter. We'll need a ISO offset, which is basically just going to make a volume out of this. And so we've got our volume here. 60. No, that's too much. 30. And then we've got our scatter. And because otherwise, check what will happen otherwise. So if I just put the scatter here, it's going to shatter on the surface and make chunks on the edge. So now if I make a volume, it gives it information in the middle, and then I'll scatter that, and that happens. This ISO offset I use all the time. There's various little functions and whatever. Just click here and you'll go to the help file to explain to you exactly about that node and what's going on and all that kind of stuff. Let's do a Voronoi fracture. Let's pull those points. Check, it's cooking now, which means it's calculating those node trees. And then let's go to out. So now, what we're going to do is we're going to make this an RBG fractured object, which means it's going to take into account all the pieces. So now, it gives you a little option box. You choose packed. Fractured is the old version. Packed is the packed primitives, which is the new memory efficient way of working. It's pretty handy. So cool, let's go in here, and you'll see here this node type has changed to a packed object. So let's go back up here. Let's create our ground plane again. Let's show our tree. And let's go. Sims away. I think I put too many points in. But screw it. It looks kind of cool anyway. Cool. So let's just make this 50 frames. Apply. What we're going to do is let's come back in here and make the scatter less, so 20. See, now I just run the sim again and now it's 20 pieces. Amazing. Okay, cool. So that's dynamics. There can be a whole lesson about dynamics, but I won't actually do that yet. I'll do a whole separate thing. So yeah, so let's go back in here and you'll see that the pig sim comes in here. So now what we want to do is we will obviously want to save this. So let's save it, and now we can cache it out. So we can either use a file cache like this and plug it in and then specify the file cache. We can use a DOP IO node to reference it in based on this. We can use a file node to plug it in, and you'll just write BGOs and set this to write, and you'll play through your sim. What I will do is I'll use a file cache. So I'll throw it in here, and in here I'll go, okay, cool, I want to use fstart and fend, $hipgeo is fine, and I'm going to just say render. So now what it's going to do is it's going to launch a little render, if it hasn't already. So let's see here what has been created. Yeah, geo, there we go. Sure, that was quick. Oh yes, of course. Because it cached originally, it played through and it went blue here. It means it already had these in RAM, so I just wrote them out. Cool. So now what I do is I just go load from disk. I can either come here and point to that file, so it'll group all the frames together as one option, or I can just leave this here, and as long as I don't change my file location or the hip name, it will just read that in. So now you can come here and scrub it back and forward or whatever. Cool. So that's nice. So that looks beautiful. Let's drop a ROP node, and I'm just going to color this black with a C button. I brought this up, and I'm going to put a mantra node down, and I'm going to call this beauty. Now it needs a camera to run, and we don't have any cameras. So let's make a camera. Let's go lights, pick a cool spot like that. Hold control and hit camera, and it's going to make one based on our camera, current camera angle or viewing angle. Cool. There we go. There's camera one. If I come in here and I name it camera one, or mirror, camera one, it is not going to read it. Oh, it does change it automatically. Oh yes, because it already referenced camera one or cam one. So when you change it, luckily this will change. But if, for example, you import an Alembic camera, then you'll have to come here and link it to the right camera. So cool, let's take a little render. So let's pick our ROPNet, ROC camera, or we can pick camera one, and let's hit render. So there we go. That's it in all its beauty. Unfortunately, it looks terrible. So what can we do to fix this? What can we do? First off, let's create some lights. So let's tab, hit light, or you can pick one of these lights, up to you. I will call this key light, and I'll go in scene view, unlock my camera, and I will pick this up, and I'll change the light type to grid. Okay. Hit 2, move it over there, rotate it, go up. You can also look through light, so if you want to do that. But again, you have to lock your camera. So that's a key light there. We can copy and paste. Let's look through key 2, or the next one. Let's have that one there, like that. We'll call this one full. And let's do copy and paste, and let's do a rim light. So a 3-point light setup. Rim light. Maybe something there. Cool. So let's unlock and pull out of that. So render view, preview render. Super bright. Super bright because there's 3 lights. The key is fine. Fill is a bit bright, so let's pull this down to 0.5. And the rim light, let's change its color. So you can either let your thing freak out. You can either add RGB from 0 to 1, or you can hit this one, or you can tap here and it'll give you RGBS, HSV, and TMR. So let's pick a red color so that we can see where the rim light actually is coming from. So now you see my problem is that I now have this render viewport and I want to change something in my scene and I can't. So what I'm going to do is I'm going to make a new floating window. I'm going to make this the render view. I'm going to squash it down. I'm going to hit render. And it's going to preview here. And then I'm going to go back to my scene view and I'm going to tweak my light. Hit space. Sorry, this is just a Wacom issue that it keeps freaking out like that. Let's go to area. Let's make this 10 and 10. Oh, that's a bit much. Let's go 5 and 5 maybe. Render that out. Yeah, okay, so that rim light's looking pretty good. So I want white, so 1, 1, and 1. Okay. Happy days. If I wanted an HDR, I would come in here and hit environment light. Same thing, I can tab it and write environment light, and I'll do the same thing. And here as well, load my HDR map. So let me go and grab one. Textures. Hang on a second. Yeah, the Wacom freaks out if you have this preview running at the same time. So let's go HDR. Let's pick, I don't know, HDR storage house. There we go. HDR there. Let's do a preview. And you'll see if I switch all of these off, see the Wacom freaks out. Then your HDR is going to work nicely. Cool. So let's set this down. Well, let's keep this at 1 actually. And let's make a material for, we'll switch our materials back on. So what we're going to do, stop this, minimize that. Here's a little tricky trick that I learned. So what you've got here is you've got shop material, okay, primitive attribute. What that means is that it has UVs and it has a texture applied to it based on its UVs. But when you go down here, the dot network, the dot path and whatever, it doesn't have that primitive attribute. So what you have to do is pull it from here. So so let's do a transfer. So attribute transfer. So transfer objects to, transfer objects from. So again, using the out node. Okay, and there you go. You see it's already picked up the texture by default. So what you do is you come in here and you'll say, okay, cool, no, I want material, shop, and name, for example. And here you can put in P. I don't think you need P for this, but so that material is going to work. Alternately, you could add a material node here, and in this material node you could reference the pig. That would work too, if this wasn't a thing. So what I've done is I've just deactivated this, but since we have that, we don't need that. So let's keep that attribute transfer in. I want to keep those UVs. Nice. Okay, cool. So let's null this out. So let's call this out render. Cool. Because if I named it out, it would just rename it to out1, which is not what I want. It's not the point of this. Okay, cool. So we've got camera, we've got sim running, we've got shaders. We now have do we have an inside of that? Fragment. No. Set of pack params. Create name attribute. Cool. So that's all working nicely. Let's call this something great like beauty. Let's copy paste and we'll make a shadow one. And then let's put a switch node in here. Let's put a copy paste matte one. Okay, cool. So let's just in here clear this out, and in here clear this out. We'll go up here. We'll move our lights over here, and we will color them all this tasty yellow. This should be like a purple because it's a sim, and yeah. So let's make a shop network for our general shader stuff. So what I'm going to do is I'm going to make a shadow material, shadow matte, and then I'm also going to make a constant. So this constant is what I'll use for RGB mattes. So copy, paste, paste. So this will be red, this will be green, and this will be blue. So, and then this will be okay. So now what I'm going to do in the pig is I'm going to re-render my sim, which is done, and then over here in the shadow I'm going to hit the shadow matte, and in mattes I'm going to hit red. Then I'm going to make a grid. I'll call it floor. Inside here it's going to be that with switch, material, and a null. Okay, so this will be beauty, This will be just switch, this will be out, and this will be copy paste, paste, and this will be shadow, and this will be matte. Okay, cool. So here, what I'll do is I'll just make a, sorry, I'm going really fast. I'm running out of time here. I'm going to pull in a Mantra surface node. Like I said, broad strokes, guys, but I'm just going to call this flat shader. I'll just call it gray. And then I'm going to link this into our floor in the beauty part. So gray, this is, and you'll see what I'm doing all of this in a second. And then we did red, so let's do green. Okay. So what I've done, let me save this. So what I've done is I've prepped to spit out my beauty paths, a shadow, and RGB matte for what's going on here. Let me just hide this from the render. So now when I do a render, you'll see that pig looks great. Okay, let's move him along. Okay, cool. The pig looks great. Now, when I switch the pig to the shadow, what it's going to do is it's going to only render black, and it will have an alpha channel for where the shadows are. So let's do that. So let's hit 1 here, and then we'll render that out, and you'll see it's basically done like an override. So if I hit A to get the alpha channel, you can see there it is not working. Why not? Let's do that on the floor as well, actually. Let's do, let's render this out. Oh, you see the floors worked. Okay, so we got A, I hit A for alpha channel, and you can see in the alpha channel there's all the shadows. Nicely. For some reason the pig hasn't worked. It is on 1, and the shadows, maybe this is different. Oh. Okay. Let's just see here. Okay, cool. So if I wanted this pig to just be a black matte, I could do that. I could say shadows or matte shading, and it will cut it out and use the shadows like that. If I wanted it to receive shadows only, I could hit shadow, type in shadow like that, and it would receive shadows from the floor. There aren't any at the moment, but I mean, whatever. And you have all these other drop downs like visible underneath primary rays, phantom, which means it's invisible, but it still casts shadows. Yeah, there's a bunch of these options here. So what I'll do is I'll set these with takes. Sorry, this video is getting a bit long here, so let me save this. So let's render the beauty paths out. So let's go back here. Let's hit 0. Let's hit 0. And then let's go to our mantra node. Okay, so on the mantra node, we are going to just set some stuff up for render. Here you change this to current frame range strict. It'll obey your start and F ends. If you want to change that, you hit delete channel, and then you can fill in whatever you like. Here's your camera. this is takes. You'll pick whatever take you have. You can override your camera resolution. So right now it'll render based on the camera here in view. This resolution. So each camera can render different resolutions, which is nice. For this, we don't want to do that, so we will render a specified resolution of HD. Pixel aspect ratio is the pixel aspect ratio. If you are doing 3D and you don't know what that is, Google it. It's quite important. Your output picture, this is where you're going to save your rendered files. So $hip slash a folder called render slash hip name, which again is this pig drop, .os, which is beauty, $f4, .exr. $f4 is a reference to the frame number with a padding of 4. So if I middle click on here, you'll see it'll tell me exactly where it's going to render. And then it will go here. So it's going to go frame 31 here with a padding of 4, so adding 2 extra zeros. You can do hip 5, hip 27 if you want. I mean, it's really up to you. Output device is your file types, info from file name. So if I came here and wrote PNG, it'll write out PNGs. If I wrote EXRs, it's going to write out EXRs, unless I force it here. Output, this is your pixel filter. So Gaussian, Catmull ROM, all that kind of stuff. 16-bit float, this is where you'll hit your bit depth. So 32 if you want 32, 16 if you want 16. Your output gamma is here. So if you want to gamma things up or whatever, you can do that here. Extra image planes are things like reflections and diffuse passes and stuff like that. Right now it's not going to render anything. It's going to, well, it's going to render a beauty pass and that's it. But you have to switch them on, otherwise they won't render. Oh, that's still in here, so let's just go back here and switch my ping back to star, which means render everything. So here, if you want to get diffuse and all that, you have to switch this on. So direct lighting per component, these are your components. Indirect lighting, so you'll get direct, diffuse, reflect, shadows, or indirect, diffuse, reflect, coat, refract, all that kind of stuff. These are all functions relating to your shader, which I'll go through in another video. So let's switch those on, and you'll see it'll rerun this, and now you've got just plain diffuse, you've got reflection, you've got indirect diffuse, which is nothing, reflection, etc. It'll combine them into one EXR, a multi-channel. If you want to add extra image planes, you'll do that here, and you will just pick here like a direct emission or indirect unshadowed or shadow matte or whatever. If you want to switch that off, you switch it off here, or you can just kill it. Deep output I've never used. Metadata also never used, but I mean you can write in if you want to, and your metadata will be attached to your end file. Rendering is where all your render settings are. Right now it's sitting on ray tracing, so let's switch to PBR, physically based, and then you can start doing things like in your limits, adding diffuse bounces, which is kind of like a final gather bounce, and all that kind of stuff. Your pixel samples here is your anti-aliasing and quality, basically. Actually, no, I lied. This is anti-aliasing here. Your quality is this. Actually, no, this is anti-aliasing. Sorry, I'm being silly. Yeah, so I could start off as 3, but 7 is what we use in production. You can go higher if you want. This is your ray samples. Min samples means it's the minimum amount of samples per per area that's gonna sample. This is a max. You can put this up to 1,000 if you want. If there are not that many samples, it doesn't matter. Where you want to overdrive your samples is in min. Noise is directly related to your quality. I mean, all these things, if you've used V-Ray before, I mean, this is pretty self-explanatory stuff. Shallow volume, shadow quality, volume quality is all for volumetric stuff, and all this other stuff. Limits, here you'll do your refraction bounces, volume bounces inside the volume, light decays, all that kind of stuff. Shading, here you can add extra paths if you want. Well, rather what it's going to do is it's going to say, okay, cool, diffuse components is going to be called diffuse. You can call this chicken if you like, but just make sure that in image planes, when you want this output, you're just going to call it chicken. And then you'll see that your diffuse channel will now be called direct chickens, which is kind of cool. Your renderer, this is your render tile size, so it's this size, your bucket size. You can change that to 32 or whatever you want. Usable processes, I mean, all of this stuff is pretty self-explanatory stuff. Dicing is your shadow quality. Statistics is a error and a debugging function. So you can turn up your verbosity level and you'll get a better readout in your renders. Enable depth of field, allow motion blur, geo samples, all that kind of stuff is all here. Sure, sounds like some cats are going at it. These are objects in your scene, or these are a reference to objects in your scene. So right now, candidate objects is basically saying render everything. Now you can force objects. So say you didn't want, I don't know, the pig's ear or something. You would come here and reference the pig's ear, and it, well, you would come here and reference everything except the pig's ear, and then it wouldn't render the pig's ear. Or you could phantom that ear so that it would cast shadows, but it wouldn't be rendered. Or you could just add the pig's ear in here, and it wouldn't be rendered at all. No matter what is set here, this won't matter. It gets overridden. Headlight creation creates a headlight if there's no lights in your scene. Driver, I mean, this is set to mantra when you're rendering locally. If you're not, then you will render HIP files. I mean, sorry, IFDs, which is like a scene description, and then you'll use that to render on your network. Yeah, cool. So that's what I want to do. So now I want to hit the big render. So let's hit stop. I'm happy with the way this looks. So let's save. And then let's hit the big render button. And there we go. There's your batch render. Off it goes. Referencing all your files, cooking everything. You can see you've got a little readout here of what's going on, and it also explains what's happening here. Hey guys, so I'm back here after the render's completed, and just before we get going, I'm going to show you the render. I changed a couple of settings here. I dropped my pixel samples here from 7 to 4, and I dropped this back down to 7, and these limits, reflect and refract limit, went down to 2. Just to speed up the render. It was taking a little bit long, so yeah, that's pretty much all I did. So let's have a look and see what it looks like. So obviously it's going to be in where our HIP file was, under render, as per our little script here. So HIP file, render, HIP name, and you can see it's pig drop version 1, which is your HIP name, dot beauty, which is the name of your mantra node, dot 0001.exr. So all that works out, and let it just cache through, and there you go. That's what the render looks like. Nothing too exciting, but still everything's there, and obviously your direct passes are here, which don't show up. There's your reflect pass, which is baked into your EXR. There is your indirect chicken pass, your codes, refract, and all of that stuff. Obviously, those volumes refract and codes won't show up because we never switched them on the shader. But yeah, so that's what it looks like. All good. So I hope you guys enjoyed this. I hope that you found it informative and learned a little something. And I hope I know it was a bit long, but we got there in the end. So yeah, let me know what you think, and cool. Look out for the next one. Cheers.